Section 2 for area, we're going to talk about trapezoids, rhombi, and kites. Okay. I know since the rhombus is a parallelogram, we technically can use base times height to find the area, but we can also use the equation that works for kites. Okay, but we're going to start with trapezoids. Okay. Just like with triangles and just like with parallelograms, the height has to be perpendicular to both of the bases. Okay, since the bases are parallel, if you know one of these is a right angle, this is also a right angle. Okay, and to find the area, we do 1/2 the product of the height and the sum of the bases. Okay, and this small 1 and this small 2 to the bottom right of these B's just mean that there are two different bases. Okay, this doesn't mean that we're going to square the base. It's just, hey, B1 is one length of the length of one of the bases. B2 is the length of the other base. Okay, so number 1, pretty straightforward. All right, remember the bases are the parallel sides. All right, the height, and we've seen this with triangles and parallelograms, height can be outside. So our height is 16. One base is 30, one base is 18. All right. If you want to do this step by step, we can. 30 plus 18 is 48. 1/2 of 16 is 8. 8 times 48 gets us an area of 384 square feet. All right, but also if you want to put this into your calculator, including the parentheses, it should get you that answer there. Okay. I want you to try number 2 on your own. All right. If you have questions, we can talk about it in class. Okay. We're going to do 4 and 5 on our own. Okay. And then you're going to try 6, 7 and 8. Wow, I did such a good job numbering these. 7 and 8 you will do on your own. They'll be very similar to 4 and 5, just without a picture. Okay. So here we're given the area. The height, or the distance between the bases here, is 11. But right now we only have one of the bases, so we're actually solving for the length of the other base. Okay. First thing that I like to do, and you don't have to do it this way, but this is the way I like to do it. I multiply both sides by 2 because that eliminates the fraction. All right, 214.5 times 2 gets us to 429. All right, on the right side, we're still left with 11 times 16 plus B2. All right, 2 options here. We can distribute, or we can divide both sides by 11. Okay, and we're looking at then 39 equal to 16. That's a letter B, not a 16. Come on. (16 plus B2), and to find the other length of that base, we subtract 16 from both sides. All right, and that means the length of our second base is 23 yards. Okay. Example 5 here, though, we know both of our bases and the area. We don't know the height. All right, so we're just filling in the pieces that we know from the picture. All right, I'm still going to multiply both sides by 2. All right, that eliminates the fraction. I'm looking at 328 equals, now 12.8 plus 20 is 32.8 times the height. Okay. Divide both sides by 32.8. And our height turns out to be 10 feet. Okay? So again, 7 and 8 here, it's the same kind of problems as 4 and 5. You don't have a picture. You've got to pick out that important information from the words. Okay, so try those on your own. And we're moving on to rhombi and kites. Okay. The diagonals for both rhombi and kites are perpendicular. Okay. And to find the area, we multiply those two diagonals and divide both sides by 2. I'm sorry, not divide both sides by 2. Multiply and divide by 2. Boom, done. Okay. So number 1 here, we're looking at one diagonal is 8 meters long, one is 15. So 8 times 15. Divided by 2 gives us an area of 60 meters squared. Okay. All right, so this was a kite. One of the diagonals of a kite is bisected. All right, but number 2 here, we're looking at a rhombus. And the diagonals of a rhombus both of them are bisected. So over here is 7, and then this other part down here is 6. All right, so keep in mind we need to multiply the length of the whole diagonal. So left to right, we've got 14. Top to bottom, we've got 12. So to find the area, we say 14 times 12 and divide that by 2. We get an area of 84 millimeters squared. Okay. Number 3, we've got the area of a kite. We know one diagonal is 24 meters long, and we want to find the other diagonal, okay? Here we can look at 24 divided by 2 is 12. And then divide both sides by 2, not by 2, by 12. And that means the length of the second diagonal is 38.75 meters long. Okay. Try number 4 on your own. All right, this is one of our diagonals. You are looking for just this part right here. Okay, that is what X represents. Okay. And we'll do 6 together, and then I want you to try 7 on your own, okay? Here, one diagonal is 4 times as long as the second diagonal, okay? So we know the area is 72, and one of our diagonals is 4 times the other, so we're going to do still multiplying those diagonals, okay? I'm going to multiply both sides by 2. What I'm left with over here is just what was in my numerator. So we've got 4 times that second diagonal squared, okay? Divide both sides by 4. All right, and since we said diagonal times diagonal, we're going to find the square root of both sides, which means one diagonal is 6 meters long, okay? The other diagonal is going to be 4 times that. Okay? So try 7 on your own. And then if we've got questions, we can talk about those in class.